Hello Internet, welcome back to our binary clock. In this episode, we are going to be actually making our clock tick. Right now, we have this, which is just a single user control that shows a set number of boxes, I guess, and it's coded to fit whatever bit array we pass in. We also have a way to encode any number into binary so that we can represent it here. So what we want to do now is we want to write a task that's going to actually, every second, we're going to read the current time down to seconds. So we're going to have hours, minutes, and seconds. And we're probably going to use 24 hours instead of 12 and AM, PM, and just discard that and just use all the way up to 24 and then just wrap that. So what we need to do is stop this, jump out of here. Sorry about that. I was screwing around with the profiler. Anyway, this is what we have. We need to do some other stuff. So we have this main page. And here is how everything is happening right now. Currently we have a task already that is actually just infinitely looping and doing our background change. I should reiterate, this isn't how you want to do a background change. You can use storyboards for that, and it's much better at it. This is sort of a hack just to kind of prove that concept out. So we can actually use this code. So I'm going to create a separate, we'll call it the clock. And so what we want is we want a clock task. I guess that works. And so how this is going to work is it is going to be a public class, and we are going to create it just like that. And then it's actually going to have a task inside of it. So this task is going to be the timer tick that we're going to do. And then we actually want to store, I guess not the current date time, but we want to fire off some sort of event that we can tie into. Why am I doing this? We don't need to do this. Hold on, rewind all of that. We don't want to do this. Bad start. We'll pretend like that didn't happen. Except I have my volume super loud. Okay, sorry about that. So, ignoring that, we are going to be using something else. There's actually a timer. We can use a timer. Timers already exist. Why did I want to create a timer? Don't ask me. Anyway, so timer, dispatch timer. If that exists, yes. And so a dispatch timer is going to be, think of it like an event that occurs every set amount of seconds or every set amount of time. And it's going to use a dispatcher to actually fire off the event. And that's really important because for UI elements, remember, they have to happen on the UI thread. So this dispatcher thread, or dispatcher timer rather, automatically makes sure that all of those events that you see are already on the main thread, so you don't need to worry about that yourself. So if we create a, we can just call it the clock, I guess. And we'll just say the clock is equal to a, well, let's say create clock. That's probably the easiest way. And then we will click the little red light bulb and create a method for it. And then all we need to do is actually pass back a clock. So I'm going to use a var here, which is just going to automatically have C# automatically figure out the type. So we'll do our clock equals a new dispatcher timer. It doesn't take any arguments. And then we just need to specify a few things. The interval, we can actually just start as 1 second. So if we just do from seconds of 1, that means every second it's going to tick, and then we can plug into that. Next, we have our clocks is enabled and start and tick. I'm just going to start it, and that should be it. The only other thing we need is there is a tick event, which we are going to actually want to plug into. So what I'm going to use is I'm going to use a lambda here. Oops, that was a P, not a, there we go. And so think of lambda expressions as sort of anonymous functions. That's the easiest way. That's the easiest way to think about this. So to walk through this line, I guess we could call it, if I put everything there. So here's what this is going to do. We have a clock.tick. That's an event. It's a C# event handler. And then we are adding a list, or we're adding some sort of action to that event. So think of events sort of like a list of actions, and then objects call them, and they do that. Our notify property changed is one of those. So how this works is we attach something and we say, these are the two arguments that it's going to accept. In this case, it's the object and the sender, or the arguments. I just use O and E because I don't think we're not going to need them. So they're just there for mostly for show and just to match. So your functions need to match the signature of your method that you're binding to. And so if I delete this E, for example, or both of them, it's going to have absolutely no idea what I'm talking about. And so it's the easiest thing to remember is the standard event, I guess, event arguments is that there's an object that is the sender of whatever it was, and then there's the arguments attached to it. And so I usually used O for object and E for that, and that just kind of gets them out of the way. If I'm going to actually use them, then I'll give them better names, but for now we don't really need that. And then this little arrow thing is just signifying a lambda. So this part, the highlighted bit, is the actual lambda expression. Everything else is just to actually add that lambda to our event. So everything inside of this brackets is just like we were declaring a standard function. So what do we want? We want to set the current time, which means I think the best way to do this is probably to do our view model dot current time equals datetime dot now. So current time doesn't exist, but what we can do here is we can actually have this setter be a little bit smart, and so that when we set the current time, the idea is this will actually trigger a number of updates that will actually update each of the columns individually. So this is all we'll need here, and then everything else can be done in our view model, which should be okay. I may go back on that in a second. Actually, now that I think about it, let's not do that. Let's update view model for current time, I guess. So we'll do datetime.now and pass that in. That's more so we can actually test this. If you explicitly specify your parameters like this, you can actually more easily test it instead of implying things, because then you have to kind of bend the rules a bit and override them, and it gets messy. This way we can just test this method without anything else getting in the way. We just pass everything in. And since our view model is a reference, we don't lose anything by passing it in if we set some values in it. As long as we don't override the reference, as long as we don't say view model equals some new value, it's going to be fine. So I think we can stay there. So if I create a method here, what we want is we want to take our current time and then translate that into some values that we can actually use in our clock. For now, I'm not going to actually do any of that. I'm actually just going to take the main view model and plug in our test data and say, where's our converter? I may have lost it. It's an integer to Boolean array converter, and we want to convert to Booleans, and I'm just going to do the current time dot second. It needs a length. So 1, 2, 4, 8, 16, 32. Let's just do 8. And that should be more than enough. That should get us up to 256. And our seconds can only get up to 8 or to 60, so we should be fine there. And then we just need to set our test data, which it doesn't like. Is that because we hacked this? Yes. Okay. So we need to actually give this a setter now, which we can do. So if our test data is not equal to our value, then we want our test data to be equal to our value, and we want to do something else. Yeah. We want to do property changed and do a null continuation. So that's, if you do a question mark period, we covered this before, but the idea is the question mark period is going to only complete the function if it is not null. If it's null, it's just going to skip it. And that's precisely what we want. We don't want to call this if it's null, because that won't work. So then we just need a new property changed argument of the name of test data. So this isn't optimal by any means. There's still a lot to do, but theoretically, this should get our seconds rendering to our main page. And so I'm just going to actually we can probably keep it as is, and just run this, and we should see it tick up every second. And if we do, then we'll know that everything's broken. Sorry. We didn't return our clock. That's required, because we're setting it here. And now that I'm looking at it, actually, we're setting both of these variables here, and we don't want them to be set again. If, for example, somebody comes in and overrides this clock reference, that's bad. It's probably going to break our app. So we can actually put in some compile time checks to make sure that doesn't happen. And the way we do that is we declare it read only. And we can do that for the color task, because that's also only updated here. And we can do that for the main view model, which means we'll never be able to override this reference. So we can just kind of pass these around, and then if we try to do that, the compiler is going to yell at us. So if I try to do view model equals a new main view model, we're going to get a read-only field cannot be assigned error. And that's because with read-only fields, you can only assign to them in the constructor or by default. So like our main view model is initialized here. These both have to be initialized here. And they'll throw another error if we don't initialize them, I thought. Ignore that last one. That was wrong. I thought that was true, but apparently not. That must be a Java thing. I think that's like a finally. Anyway, that's not really relevant here. What is relevant is we are going to start now. We're returning our clock, so it should work. We should be able to count up and get everything working. So let's see what happens. There we go. So it is counting. You can see, kind of hard now that it got a little bit white, but you can see it is slowly counting up, and it is actually properly doing binary. So that's working. That's promising. So here's our seconds. Our clock isn't going to look like this because we're going to do each digit individually. So you're not going to have to be able to figure out what is this 60 or whatever. It's going to be a little bit easier to read because we only need to go up to 10 for each of them. So there's going to be 4, I think, instead of 8. And that's a little bit easier to read at a glance. Besides, who cares about how many seconds there are in a time? It just looks cool. So, ignoring that, we should be able to actually turn this into our actual clock. So, what I want to do is I want to actually make another list. Well, do we want another list? Probably not. No. Okay, ignore that last one. We're going to skip that. What we are going to do is add a bunch of other things to this. So our test data is going to be gone. That we can actually initialize to a new Boolean array of size 0. There we go. And I'm actually going to have this be, how do we want to do this? Do we want seconds and then just split that up? So there's multiple ways we can solve this. I'm going to pick one, and I don't know if it's going to be the best. What we could do is we could have a list for every, or we could have a property, sorry, for every single element. So we could have like seconds 1, seconds 2, minutes 1, minutes 2, hours 1, hours 2. We could do something like that. The issue with that is that that's a lot of work, because then we have 6 fields that we have to deal with. We could condense that down all the way down to a single enumerable, and then have something else handle actually constructing each of them and actually placing them into that list. So we'd have a list of lists of Booleans. So just a list of each of those stacks. Or we could combine like just the seconds, for example. So the 2 seconds columns would be combined into a list, and the 2 minutes would be combined into a list. I imagine that would be a lot more work. I think the best solution, though, is probably to just make everything enumerable enumerables. And the reason for that is because it means we don't have to keep duplicating our XAML, and we don't have to duplicate our code here. That means we can put all of the actual application logic, all of the stuff that's actually putting stuff together, all of that can go into our controller class. And I think that'll be optimal for what we want. So let's do that. Let's actually, we don't need that. And then I'm going to put time data in there, I think. And we'll call this, actually, sorry, I can show you what I mean when I say it makes things easier to refactor. So when I say refactor this, let's rename it, and we'll call it our time data. So now when I do that, you'll notice this name of property changed as well, and that's just taking the name of this. If I undo it and make this into a string, like so. Not like that. But anyway, if I make it a string, actually I think ReSharper is smart enough. But if I name this time data, for example, I spelled that wrong. But yeah, so ReSharper is going to catch it and say, hey, there's this test data. Do you want to rename that too? And it will actually do it. Visual Studio itself is not smart enough to do that, or at least it wasn't the last time I checked. So this little name of thing, not only does it make your code better, but it also has that added advantage. So anyway, there's a random, I guess, tidbit. Hopefully somebody uses that. I didn't just spend a bunch of time talking about nothing. But anyway, we're going to call it time data. And it doesn't like this at all because it's the wrong type of enumerable. There we go. Enumerable. So we have a list of a list, or we have a list of Booleans, which sounds confusing, but I guarantee it's going to make sense, I hope. So we need to make that work. How do we make that work? The best way, we've been putting all of our actually, We could do that. That'd be cool. Sorry, changing course again. Sorry, I'm sounding like a Canadian. But anyway, I'm thinking we could just pass the date and use a converter to get that enumerable object out. And that might make things way easier. Or at least cleaner. Because that way we're not handling conversion inside of here, which is gross. Might be worth investigating. Regardless, we are not going to do that right now. I'm going to do a new list of enumerable bools. So we're declaring an enumerable list, or a list which inherits enumerable. And we're just going to quickly throw a bunch of stuff in there. That should work. Ish. Okay. So we want to take the seconds, the minutes, and actually we want seconds at the end because it goes left to right. So we want hours here. So one thing to keep in mind with these functions is the ones that return ints, so hour, minute, second, those are each going to return only that property from the time. So like right now it's 11:31. So that means hour is going to return 11. It's not, and then minute is going to return 31. It's not going to turn 11 times 60 plus 31. If you want something like that, you want to use total. Did that go away? Hold on. What? Well, that's interesting. I could have sworn that was there. There we go. So you want to use the actual time of day. You want to get a time span from that. And then you want to use the total functions to actually get whatever it is you're looking for. So like total days and total hours is going to return the total number of hours that you are at, or the total minutes. And those are going to be fractions. So if you need that for any reason, that's how you get it. Minutes. And we should just be able to plug that in and then close it. So this is shorthand for pretty much what this is going to do is it's actually going to, first off, it's going to create a list, and then it's just going to call add, the function add on that list, and pass in each of these arguments. This shorthand just kind of removes that extra step. So I wouldn't need to save it here and then add each of them individually. This is going to do all of that, and then it's going to assign it there. So it's just a little bit quicker. Quicker and I guess simpler. So the next thing we need is to actually bind this thing. So we have our binary list view. What we need here is an items control. And we used this before, we used it in our binary list view. But we're going to do pretty much the exact same thing. Actually, if we're going to do the same thing, let's just copy and paste. So we have everything here. We can just copy it over to our main page, and everything should be fine. Then I can just pull it in like that and replace our data template with our binary list view. That's the only thing I'm going to change, and I'm going to make it horizontal. So it's going to go left to right. Then we just bind like so. Item source is equal to our time data. And I think that should be it. So there shouldn't be anything else. I just had to change it so the item source for this items control is coming from our time data, which is going to map to here. So we're mapping this enumerable Boolean object onto our main page. We're going to organize it horizontally. And then each of those elements, so each list of Booleans is going to be represented this way. And so this is just saying take that value and use it. So theoretically, we should be able to run this and we should see 3 columns, and one should represent hours, one should represent minutes, and then the next one should represent seconds. So the minutes or the hour and minutes probably won't move, but our seconds should be ticking by. And we forgot to center it, but good news, we are getting things, and 1 plus 2 plus 4 plus 1 plus 2 plus 4 is 7 plus 16. Is that right? Yes, 23. Correct. Cool. So we have 23 here for the hours. It's 11, so we're good. I say 11, it's actually 23 because I'm filming this at night. And everything else looks good as well. So I think we're good to do stuff, which is reassuring. Now all we need to do is actually split this up so each of them are in separate columns and center it again. And then we should have a binary clock. We'll need to obviously touch it up a bit because that Technicolor background is kind of driving me a little bit insane, but that's fine. We can actually get rid of that if we want, but we'll leave it for now. It was an interesting experiment. So let's expand this. Let's make this work better. And so the way to do that is actually to go in here and grab out each of our components. So everything can be represented in decimal. Everything is decimal, and it's 2 digits, which is important. So we can actually use the same trick we used for the binary conversion. We used a left shift of 1, which is the same as division by 2. So we can do the same thing in decimal. We can just divide by 10. So to get that, we can do a long integer array. I'm trying to think if we want to stick this into an array and just do it that way or not. We won't for now. So do a variable of second 1. Actually, we'll do, seconds equals a new int array, and we will do current time dot second. And we're going to divide by 10 here. Divide by 10, and then current time dot second, and we're going to mod 10. So mod is this percentile sign, and it's going to get the remainder of it. So if we have, say, 15, and we divide by 10, the remainder is 5, which means we got our first digit. So this is going to get us our seconds, or our tens place, I guess. And this one is going to get us our ones place. And because of the math, it should avoid any overlap. So this is going to truncate because it's division of 2 integers. So any fractions are going to be rounded down. So that should be covered. And then our mod should also be covered because it's never going to exceed 10, and it's always going to just take into the account the first ones position, just the remainder. So we should be able to do that again for minutes and hours. Oops, there we go. And then we can take that, plug in our hour there, and then we just have to add it to our array, and we should be in a pretty good position, actually. So now we're here. All we have to do is remove these references to the current time and just use hour 0. And we can actually just use 4 because we need to get up to 8. So 1, 2, 4, 8. And then we can represent everything between 0 and 10. So 4 should be more than enough. I'm just going to copy that 6 times, delete everything else, and then alternate ones and zeros. And then this is going to be our minutes. And then the last one will be our seconds. And then the only other thing we can do is we can actually cut some of these down. So seconds only goes up to 60. And so because it only goes up to 60, we can actually cut the tens position down to 3, because we just need 1, 2, and 4 to represent 6. So we can do that. For minutes, same thing. So we can cut that down to 3. And then for hours, our tens position is only going to go up to 2. So we only need 2 there. Because the most we can represent is 24. We'll only actually get up to 29, or 23, sorry, but regardless, we're never going to exceed 20 minutes, or 24 hours in a day. So that should be good. And then we just need to start it and see what happens. Probably something interesting. Hopefully something interesting. Ooh, it centered everything. Well, that wasn't what I was going for. I kind of like it, but that was interesting. I don't know if I want to change that. Yeah, that's going to be hard to read. What we're going to do is we're going to actually lower everything to the ground. So let's actually get all of the centering out of the way. We'll horizontally align it to the center and vertically align it to the center. And then so that was aligning the entire panel that it's rendered in. But we want to actually align the individual components. We want to vertically align them to the bottom. So all of them will be tucked down to the bottom, and they should be in the center of the screen. They won't fill the screen because we haven't gotten that far yet. That's going to take a little bit more time, but we can play with that in some other video. Cool. So we have binary. It's counting, it's doing its thing. It's 11, 42, and 30, 40 seconds, 42 seconds. So here we go, binary clock. And it counts, it does its stuff. It's got a weird background, really weird background. But it does what we set out to do. So the next few steps are going to be, first off, we're going to actually bind this background to the current color, and we're going to replace the horrible animation. And we're actually going to use storyboards, I think. We also need to spread this out and actually get it to fill the space. And then there's some actual Universal Windows platform stuff I want to do, like a live tile, so you can actually see this in your start menu. I think that'd be really cool. I don't know how you do that. I got really frustrated with live tiles when I tried to use them because they didn't used to be good. They used to be kind of crap, and they've gotten a lot better. And in Windows Defense, they did a good job. They got it better. I just haven't kept up with it because I didn't like it the first time, so I stopped. But anyway, I think we can dig into that in the future. But for now, I think we're in a pretty good spot. It's usable. It does what we wanted. Now we just have to make it something cool. So I'll leave this here, and if there's anything you guys want to see, let me know in the comments. If there's something you guys want me to change or improve, love to hear that as well. But until next time, see you, Internet.